Hello, I'm going to do a little bit on section 6.8. In this section, we're talking about the standard form of an equation. Now, let's start back in a little bit of a review. We have done the slope-intercept form of an equation. In the slope-intercept, it's always written as y equals the slope times x plus the y-intercept. We've used that, we've worked with that. That's kind of been our main focus. I will tell you, this is probably my favorite way of writing the equation because it gives you the slope and the intercept so we can do something with it. We can graph it very easily. We can make tables very easily in this form. Occasionally, it will be given to you in the form of ax plus by equals c, where a, b, and c are real numbers. So let me just give you an example of one. So if I said 2x plus 3y equal 9, okay? That's an example of standard form. So it really is just another way of writing the same thing up here. It doesn't look as nice. It's not as easy to use. Okay, it doesn't give me the slope. It doesn't give me the y-intercept. It just gives it to me in this form where the x and the y's are both on the same side and your constant is on this side. So that's the standard form. Now, there's a couple things we can get from the standard form. One, we can find the x and y intercepts from the standard form. So we can find the x-intercept, and we can also find the y-intercept. Now, if you remember, when we're looking at graphs, okay, this is my y-axis, so my y-intercept is where it crosses the y. And whenever it crosses the y, it has a number. The y value has a number, but the x doesn't. So in a y-intercept, x is always equal to 0. Because if you look at any points along this line, any points I pick along here, the point is going to be 0, 5, 0, 3, 0, 2, or 0, -2. I don't know, these are not consistent. But if you notice, x in every case is going to be 0. So it's going to be 0 in every case. And so when I'm trying to find the y-intercept, we can just put 0 in for x because I know the y-intercept has x equals 0. If I'm trying to find the y-intercept, it means I want to find a value for y. Find a value for y. We're trying to get a number for y. So that means I'm going to put 0 in for x. So in this case, it would be 2 times 0 plus 3y equals 9. And what's really nice about this is 2 times 0 is 0. So what I have is 3y equals 9. If I divide by 3, I now know that my y is 3. So my y-intercept, where it crosses, is right here at this point, where we just put it right there at the 0, 3 mark. Okay, so that's how we can find the y-intercept for this equation. It's very easy because we can just put x equals 0. And this concept will stay the same no matter what type of equation we're working with. So as we go farther in algebra, this equation this truth will always be true. The y-intercept will always have an x value that's 0. You're always trying to find a value for y. When it says, what's the y-intercept? I want a value for y. That means x is 0. It's going to be the 0 number, okay? The x-intercept is just opposite of that. If you start thinking about these points along here, they're written as -1, 0, -3, 0, or this point right here, which is 1, 0. Notice that the y is always 0. Okay, so what we're trying to do is we're trying to find the value for x. So we're trying to find what does x equal. And y is always 0. Since I'm looking for an x, I want to find x. So the y becomes 0. So what we do is we just go 2 times x plus 3 times 0, because there's my y. Y is going to be 0 equals 9. Again, the 0 makes that cancel out. So I end up with 2x equals 9. I divide by 2. So x is equal to 4.5. And so now I have my x-intercept because it's where it goes through. So if I went out to 4.5 up here, 4.5, there's my x-intercept for this line. So I know that the y is on 3, the x is on 4.5, and then I can graph this line here. Okay. Now, it's not hard to then find the slope, because we know we have this here. It's the rise, it's going down 3, so the slope is going to be going down 3, -3, and over 4.5. Okay, now that's not the prettiest form of the slope, but we can then change it either into a fraction, or we can multiply it by 2. We could multiply it by 2 to change it into a whole fraction. So like this would be, if I multiplied the top by 2 and the bottom by 2, which is that special form of 1, then I would get -6 over 9, which is -2/3. So there is now my slope of this equation. So once I find my x-intercept, my y-intercept, I can then find the slope by just using those two, because we went down 3 and across 4.5 to get to those points. So I can find my slope, and I have my slope. So if I wanted to, I can now change it into the slope-intercept form. So the slope-intercept form for this would be y equals -2/3 x, and the y-intercept, which is 3 plus 3. I'm going to show you another way to get that in just a moment, but you can find it by finding the x-intercept, finding the y-intercept, plotting those, getting the slope, and then you can find your slope-intercept form. That's one way of doing it. It's very practical, it's easy, it's not hard, it just takes steps by steps by step. So you want to have this available for yourself to look at and work from, so that as you're doing the problems, this is one way you can do it, so you understand what's going on. Okay, as you're taking notes, make sure you make the notes very clear to yourself. And I was seeing that as we're taking the test, some people weren't using notes, and I think that hurts them in some ways. But one of the things with notes is maybe keep everything I go through, I talk about, keep that all in one place. And if you keep those very neatly organized, it will be easy to go through and see where is one of those problems that we did. And you might even circle some of the things that are very important. Okay, so let me just show you. We have said this is the new equation for our line in slope-intercept. We say these two are equivalent because one's written in slope-intercept, one is written as a standard form. I'm going to show you, besides this way, how you can get to the slope-intercept form without doing all the x-intercept, y-intercept, and slope based on those, but really not too hard. This may be more confusing for others, but this is how you can do it. So we're going to solve this equation for y, because what we want is y all by itself. Notice slope-intercept form. Slope-intercept form always has y equal. So we want y by itself. Okay, so we're going to take this equation and just get y all by itself. So the first thing I need to do is take the 2x away, because I don't want it on the side with y. Okay, so I'm going to subtract it here, so I'm going to also subtract it here. Okay, That cancels it out because we do it on both sides of the equation. We get 3y equals 9 minus 2x. Or you could switch this if you wanted to make it 3y equals negative 2x plus 9, negative 2, so I put the negative 2 there, plus 9. That's the same thing, but it does get the x moved into its standard place as of slope-intercept. Okay. Now our last step is to divide. To get y by itself, I have to divide this by 3, so I divide this by 3 and this by 3. This cancels. So I get y. 9 divided by 3 is 3 minus 2/3 x, which, if I switch those around, is y equals negative 2/3 x plus 3. Notice that this and this are identical. Two ways to switch it from slope-intercept form, from standard form to slope-intercept. I find very few reasons to go from slope-intercept to standard form. They might ask you to do that, but I don't feel like that's very useful. It's not a good way. We like this form the best. So if we have it in that form, we're going to keep it in that form. It just makes sense because we can do a lot more with it. But if it's given to us in standard form, we either have to change it into slope-intercept to use it, or we use it by finding the x-intercept, the y-intercept, and we can find the slope based on that. So we can use it both ways. So again, remember to take notes, keep them very accurate, understand what you're doing, and try some of these problems that I will put up there for you to try also. See you tomorrow.